Pre-calculus review. Number 1. Functions and graphs. Example, use the graph of y equal f of x at the right to determine f of 2 equal. As you know, we're looking for y value such that x coordinate is 2 on the graph to your right. So I see the point right here. When x equals 2, the y value is 0. So f of 2 is 0. Where does fx equal 2? So this time, they gave you the y coordinate and asking x such that y value is equal to 2. So this time, you needed to go to y value 2. And you can see when y is equal to, your x value is negative 5. So where does fx equal to? That's when x is equal negative 5, right there. When x is negative 5, f of x equal 2. In other words, f of negative 5 is equal to 2. Give the domain. And you can see this graph is going skewed left. So since there is an arrow, this graph will eventually keep going to the left forever. So it is actually starting from negative infinity 2. And as you come to the right-hand side, graph actually stops at right here. And that x value is 2. So domain is the x value that the graph is taking. So that would be negative infinity to positive 2, bracket since 2 is included. Give the range. Range is the y value, and as you can see, the lowest point of this graph is right here. And that will be when y value is equal to negative 3. And because this graph is keep going up, it is going to infinity. So range of this function would be starting from negative 3 to positive infinity. Name the roots. Roots are the x-intercepts of the graph. And how many x-intercepts do you have? You have 1, 2. And the roots are x-coordinates. So you can say that the roots are negative 4 and positive 2. Next example. Given the graph of fx at the right, name the open intervals where f is increasing, decreasing, or f is constant. Typically, we interpret the graph from left to right. So from left to right, if a graph is going up, we say f is increasing. From left to right, graph is going down, we say f is decreasing. And from left to right, there is no change and graph is same, we say f is constant. So as this graph has an arrow to the left-hand side, this graph is going forever to the left-hand side. So from negative infinity to, you look at the graph from left to right, up until x equal negative 1, you can see your graph is going down, 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 from left to right. So you can say that f is decreasing from negative infinity to negative 1. And we always give open interval for interval of increasing or interval of decreasing because the end point is the changing point from either decreasing to constant, decreasing to increasing, increasing to decreasing, so on. Now, this graph, you can see from negative 1 to positive 2, you can see that graph stays the same. It is being constant. It doesn't go up, nor it doesn't go down. So you can say that f is constant from -1 to +2. And from there, from 2 to 4, this is 2, this is 4. You can see graph is going up. So you can say f is increasing from 2 to 4. But from 4 to infinity, your graph is again going down forever. So from 4 to positive infinity, f is decreasing again. So there is actually two intervals where f is decreasing. So f is decreasing from negative infinity to -1, union, open interval 4 to positive infinity. Rational functions. Rational functions is a function of the form polynomial over polynomial. Example, name the roots, vertical asymptotes, and wholes of f of x equal 2x squared minus 7x minus 4 over x squared plus x minus 20. So you can see this is a rational function since you have a polynomial over polynomial. As you know, roots are x-intercept. X-intercept is an x-coordinate such that y-coordinate is 0. And in order for fraction to be 0, you got to have a numerator equal to 0 and denominator not equal to 0. So you're going to have to factor this to see for what x value numerator is equal to 0 and denominator is not equal to 0. And what happens if a numerator is not equal to 0 but denominator is 0? Then that rational function is undefined, and that's where you're going to have vertical asymptotes. So you are going to give x value such that numerator not equal 0, however, it will make denominator equal to 0. But what if I have a 0 over 0? If there is an x such that both numerator and denominator equal to 0, then actually that rational function will have a hole on their graph. So let's go ahead and factor this rational function to find out the roots, vertical asymptotes, and holes. My numerator is a trinomial of a leading coefficient not 1. This is how I factor, and it is a very efficient way. And you would break this as first and first, since this is a result of a FOIL, but you write vertically. You have no choice. Since 2 is a prime, 2x squared will be formed by multiplying 2x by x. And then now you can break the constant term. And you know that came from multiplying last and last of a binomial. And there is, of course, many choices. -4 could be made out of -4 times +1, or +4 times -1, or -2 times +2. But you want to locate here and here right pair with the right order, so that when you multiply these two, which is the outer two of a FOIL, and multiply these two, which is the product of inners of FOIL, and you want to come up with the middle term, which is the -7x. So in order for me to obtain -7x, I will locate -4 here and a +1 there, so that when I multiply with these two, which is the outer two, it is -8x. When you multiply these two, this is a +1x, which gives you -7x, what I exactly needed in the middle of this trinomial. Then your factoring is this. 2x plus 1, x minus 4. So this guy factors as 2x plus 1 times x minus 4. Look at it. You can multiply first and first. This is 2x times x, which is a 2x squared. You can multiply outer 2. This is our outer 2, 2x times -4. This is the inner 2, which is x times 1, which gives you negative 7x, and last is the positive 1 times negative 4. Now, let's go ahead and factor the denominator. Denominator is easy factoring, right? It is a trinomial of a leading coefficient 1. And when you have a trinomial of a leading coefficient 1, you can just use the x method. And you can put the product here, sum there. Product of two numbers is negative 20. That's the last and last. And sum of two numbers is a positive 1. And think of two numbers whose product is negative 20 and sum is positive 1. Yes, that will be positive 5 and negative 4. When you multiply these two numbers, it is negative 20. When you add these two numbers, it is a positive 1. And the factoring goes x. You can put this number there, plus 5. Another factor is x. You can put this number there, negative 4. All right, so we factored this rational function successfully. And now let's find the root. So in order for numerator to be 0 and denominator not to be 0, my x has to be equal to negative 1/2. So I have one root. Since this rational function will be 0 if and only if x is equal to negative 1/2. What about 4? That's no good, because if x was 4 and 4, it will make 0 over 0, which is actually the case for the wholes. So this rational function do have a whole, since when x equals 4, we get 0 over 0. So we do have a whole, and whole happens at x equals 4. And if you want to find out what is the y coordinate of the whole, you could cancel this and plug x equals 4 on the rest of a rational function to find out the y coordinate of a whole, so that you can actually plot the whole for your graph. And let's find the vertical asymptote now. The vertical asymptote occurs when numerator is not equal to 0, but the denominator is equal to 0. So you can see if x was equal to negative 5, your denominator becomes 0, but numerator will not be equal to 0. So you do have a vertical asymptote at x equal negative 5, and vertical asymptote is a vertical line, and equation of a vertical line is x equal number. So it is actually x equal negative 5. That will be your vertical asymptote. Give the domain of f of x. Domain of a rational function is always all real numbers except x such that denominator equal to 0. So if there is an x that makes the denominator equal to 0, then we need to get rid of those x's from all real numbers. And that will give you the domain of rational function. So you can just focus on the denominator of a rational function. So you can look at the denominator of this rational function, and you know this function is undefined if x was a negative 5 or x equal 4. So domain of this f of x will be x such that x is not equal to negative 5 or positive 4. And x is element of real numbers. So this is a notation to write x such that your domain is all real numbers except negative 5 and 4. Number 3. Piecewise define the functions. Sketch the graph of f of x equal negative 4 minus 2x for all x less than negative 2. F of x equal x squared plus 1 if x belongs between negative 2 to 1. F of x equal 2 for all x greater than equal to 1. So you can see that this function is made into 3 pieces. So let's graph that. So first, for all x less than negative 2, my function is a line, and it is y equal negative 2x minus 4. So slope is negative 2. and y-intercept is 0, negative 4. However, 0, negative 4 is not in this domain, so I cannot use the y-intercept as my point. So you can pick any point that belongs to x less than negative 2 and plug it in there to get the y coordinate, and you can draw the line up to negative infinity to negative 2. So let's go ahead and plug negative 3 since negative 3 is less than negative 2. So when you plug negative 3 for x, I get y equal negative 4 minus 2 times negative 3, which is equal to negative 4 plus 6, which is 2. So when x is negative 3, y coordinate is 2. And you can do the same thing with another point that is less than negative 2. So let's plug negative 5. If x was negative 5, I will have y equal negative 4 minus 2 times negative 5. So then I will have a negative 4 plus 10, and my y would be 6. So when x equal negative 5, y is 6, which is right here. So I will draw the line, and at negative 2, it would have been 0, but it's not included, so I will have a hole there. So I draw a graph from negative infinity to negative 2. Now I need to draw the graph when x equal negative 2 to 1. And negative 2 is included in this domain, so you can plug it in there. So if I do that, y equal negative 2 square plus 1, since you need to now apply to this quadratic function. So that would be 4 plus 1, which is equal to 5. So when x equal negative 2, y value is 5, which is right here. And then when x equals 0, it is 0 squared plus 1, which is 1. And graph stops at 1, and 1's not included. So you can plug 1 in there, but put a hole in there since it's not included. And when you plug 1 in there, 1 squared is 1, 1 plus 1 is 2. So when x is 1, y value would have been 2. You can now draw the parabola that look like that. So I graphed also this function when x is greater than or equal to negative 2 and less than 1. My last piece is when y equals 2. Y is equal to for all x greater than or equal to 1. So when x is 1, y is 2, so that my hole is going to be made by that piece. So when x equal 1, y is 2, and it is constant function, which is the horizontal line. So for all x greater than 1, meaning 1 to infinity, I do have a horizontal line, y equals 2. So I finished my graph here. This is what my function looks like. Give the domain of f of x. You can see I have graphed this function from negative infinity to negative 2 not included, negative 2 included to 1 not included, 1 included to infinity. So actually it covers all real numbers. So domain of f is negative infinity to positive infinity. And the range is, what is the lowest point of this graph? It is this point right here. And it would have been 0, but that point is actually a hole. So 0 is not included, but as soon as it's above 0, there is a point there. So it starts from 0 not included to, and you can see the graph is going up, and it is keep on going to the skewed left forever. So it is actually going to positive infinity. So that would be the range of this function. Absolute value is a piecewise defined function. When you have a square root of x squared, note that it is not x. This is one of the very common mistakes that students make in calculus. So make sure you don't do that. Square root of x squared is actually absolute value of x if you want to convert it to a function without the square root. because it is something square, when it get out of there, it has to be positive. And x itself could be negative number. So you needed to put an absolute value there to make sure it comes out as a positive quantity. So absolute value of x is opposite of x if x is negative. Because if x is a negative number, opposite of that will be positive. And it is x itself if x was a positive number. For example, absolute value of 3 is 3 because 3 is a positive number. Absolute value of negative 3 comes out as the opposite of negative 3, which is positive 3. Simplify square root of negative 5 squared. And since negative 5 is a negative number, when it comes out from square root, we need to put an absolute value there. So it's gonna comes out as opposite of that, which is equal to positive 5. Sketch the graph of f of x equal absolute value of x, and this is a very famous parent function. And you can actually graph from the definition above. So absolute value of x is negative x for all x less than 0. For all x less than 0 is negative infinity to 0. So from x negative infinity to 0, your graph is y equal negative x. It is a line with slope negative 1 and y-intercept 0, 0. Although 0, 0 is not included. So graph with a slope negative 1. So you can graph that. At 0, it is 0. So 0, 0 is covered. And for all x greater than 0, it is a line with slope positive 1. So you will have rise 1, run 1. And your graph looks like this. So you will have a V shape. Number 4. Radical functions. Example. Rationalize the function and give its domain in interval notation. So I've got g of x equal 4 over quantity 3 minus radical x minus 2. How do you rationalize that? Do you recall? Yes, you're going to have to multiply by quantity 1, since any quantity times 1 is itself, so we're not really changing anything. However, to rationalize this denominator, we will multiply by conjugate of this denominator, and conjugate is two binomials such that first term is exactly the same and the last term is opposite. So for 3 minus radical, you would multiply by 3 plus radical x minus 2, and you would also have exactly same quantity on the numerator. So you can see that I multiplied g of x by quantity 1, but now from the algebra fact, you know a plus b times a minus b is a squared minus b squared. So I'm going to get 4 times 3 plus square root of x minus 2 on the numerator, and denominator, when I multiply them using special product, I will get 3 squared minus the square root of x minus 2 square. But when you square root, you will get 9 minus x minus 2, and we will give a domain so that this quantity does become positive. So we will omit the absolute value here, and when you distribute the negative, you will have 4 times 3 plus radical x minus 2 over 9 minus x plus 2 by distributing the negative, so that you will have 4 times 3 plus square root of x minus 2 over 11 minus x. The radical functions we got to make sure input is positive. So to find the domain of radical function, you set radicand greater than equal to 0 and solve for x. So if I do that, my radicand right now is what's sitting inside of radical, which is x minus 2. So I want x minus 2 to be greater than equal to 0. And when I add both sides by 2, I see that x has to be greater than or equal to 2 for this function to make sense. However, because this is also rational function, my denominator cannot be 0. So maybe not all x greater than equal to 2 is good. So let's see. I don't want radical of x minus 2 to be equal to 3 because that will make my denominator equal to 0, and then g of x would be undefined. So if I solve this radical equation by squaring both sides, this means x minus 2 would be equal to 9. And when I add 2 both sides, that would give me x equal 11. And if x was 11, even though 11 is greater than or equal to 2, 11 is no good because it will make this function undefined. So actual domain of this function, so domain is bracket 2 to 11, and 11 cannot be included in my domain, so you make it parentheses, union, parentheses 11 to positive infinity. Example, give the domain of f of x equal square root of x squared minus 4 in interval notation. So again, I have a radical function, and to find the domain of a radical function, you need to set the radicand greater than equal to 0 and solve for x. So my radicand this time is x squared minus 4. So I need to set x squared minus 4 greater than equal to 0. And to solve this, recall from algebra, you want to factor. And when you factor x squared minus 4, it is x plus 2, x minus 2 greater than equal to 0. And find all x-intercepts, which is negative 2 and 2. And since we want all x that this function is greater than equal to 0, you know negative 2 is good because when x is negative 2, 0 is greater than equal to 0, which makes this inequality true. Positive 2 is also solution of this inequality, since when x was a 2, it will make 0, 0 greater than equal to 0. And you need to pick a test point from each interval and test this inequality to see for what x value this inequality is true. So your test point then, for all x for less than negative 2, you can pick like negative 3. For a test point between negative 2 to 2, you can pick 0. Test point any x greater than 2, you can pick 3. And then you can plug it into this inequality. So if x was a negative 3 and a negative 3, then it is negative number times negative number, which is greater than equal to 0. So this inequality is true on this interval, meaning all x from negative infinity to negative 2 is a solution of this inequality. If I plug 0 and 0 for x, it becomes positive number times negative number, which is negative. And negative number is not greater than equal to 0. So this is not the solution of this inequality. If I plug x equal 3 there and a 3 there, then it's a positive number times a positive number, which is greater than equal to 0. So all x that is greater than equal to 2 is also solution of this inequality. So therefore, domain of this radical function is negative infinity to negative 2 included, which means bracket, union, bracket positive 2 to positive infinity. Number 5. Test for even and odd functions. Hopefully you guys still remember these from algebra. A function is called even if f of negative x is equal to f of x. And when that happens, it is symmetric with respect to y-axis. A function is called an odd function if f of negative x is equal to negative f of x. And when that happens, the graph of a function is symmetric with respect to origin. Example, determine whether f of x equal x squared plus 1 over x is even, odd, or neither, and name its symmetry. So you can find out what is f of negative x is equal to. So let's plug negative x for all x we see in this function. So I'm gonna get negative x squared plus 1 over negative x. And when you score the negative x, you get still positive x squared plus 1 over negative x. Is that equal to original function? Compare with the original function. No, they are not the same. Numerator is the same, but denominator is not the same. So this is not an even function. Now note that a over negative b is equal to negative a over b, since positive divided by negative is negative. So this can be rewritten as pull out negative x squared plus 1 over x. I'm just using this right now. But then you notice that this is really negative f of x. And since f of negative x is equal to negative f of x, this f is odd function. And because it is odd, it is symmetric with respect to origin. Number 6. Transformations of graphs. So let's say you have a function f of x. And if a function is multiplied by a number, it is vertical stretch or vertical compression. If the number is bigger than 1, it is vertical stretch and it affects the y value. All you have to do is really just multiply a to the y coordinates only, and that will give you the resulting graph. If a number is multiplied to x so that you have f of b of x, then it will actually give you horizontal stretch or compression. It is opposite effects for the x. If a b is smaller than 1, it is the stretch actually, and if a b is bigger than 1, you actually get the compression. And for given x comma y in the f, if you have f of b of x, instead of multiplying the x coordinate by b, you actually divide the x coordinate by b, and that would give you resulting graph. If your f of x is multiplied by negative 1, it is a reflection over the x-axis. And just like what we did with the number a on the very top, you could just multiply the y coordinate by negative 1. And f of negative x, just like what we did over here, you could just divide the x coordinate by negative 1, so you actually still get the negative x instead. If instead of x, you have x minus c, it is actually shifted right c units. If f of x plus c, it is shift left by c unit. However, if whole f of x is added by d unit, it is shift up by d, and if it's minus d, and it is shifted down by d. So anything to do with the y coordinates, it is what we see. You see a is multiplied by, since f of x is equal to y, you multiply y by a. And if you see negative symbol in front of y, you do multiply y by -1. If you have plus d on your y, you do add plus d on your y. If you have subtract d on your f of x, you do subtract d from your y. So it is the same as what you see with y's, but with x, if you see b is multiplied with x, you actually divide by b. If it is negative x, it seems like multiplied, but because you divide by -1, it is still negative x. So you're actually doing the opposite. For the minus c, you need to add c. For plus c, you need to subtract c. So with an x, you do reverse operation of what you see. Example. The point 2, -3 on f of x corresponds to what point on new function g of x, which is made by -3 times f of 4x minus 2. So this -3 is multiplied by your f of x, so you're going to have to multiply y coordinate by -3. And then because 2 is subtracted from the function, you're going to have to subtract 2 from that. And then because instead of x, you have f of 4x, x coordinate will be divided by 4. So all x and y that was on f will go to x over 4 comma -3y minus 2 on g. So since 2 comma -3 is on f, it will go to 2 over 4 comma -3 times -3 minus 2, which is half comma -3 times -3 is +9. +9 minus 2 is 7. So the resulting point would be 1/2 comma 7. Example. Given the graph of f of x below, sketch h of x equal f of -x minus 4. So when you sketch the graph of a transformation, if there is any reflection, that's what you want to do first. And since there's a f of -x, there is a reflection about the y-axis. This is reflection about the y-axis. So I'm going to do the reflection about the y-axis. So -1 comma 0, when you reflect about y-axis, it will go to 1 comma 0. And then 1 comma 6 will go here, which is -1 comma 6. And then 4 comma 2 will go to -4 comma 2. So it will come to here. And because you reflected, it will look like this. And after that, you need to shift to down 4 units. So when you shift to down 4 units from -4 comma 2, I get -4 comma -2. And then if you shift to down 4 units from -1 comma 6, I get -1 comma +2. And then if I shift to down 4 units from 1 comma 0, I get 1 comma -4. So my final h of x will look like that. This is -4 comma -2, -1 comma +2, and 1 comma -4. And here is my h of x. Example. Given the graph of f of x equal x squared, sketch the graph of g of x, which is equal to 2 times x minus 3 quantity squared plus 1. So there's no reflection this time since there's no minus in front of the parentheses and there's no minus x either. I just see that whole function is multiplied by 2. So this is the vertical stretch. My y values needs to be multiplied by 2. And because it is added 1, you can add 1. And then x minus 3, we do the opposite with an x. So I need to add 3 for all the x coordinate. So all x comma y that was on f will go to x plus 3 comma 2y plus 1 for the function of g. And I see that I have 5 points given here. The first one is negative 2 comma 4. And negative 2 comma 4 will go to 1 comma 2 times 4 plus 1 is 9. Negative 1 comma 1 will go to negative 1 plus 3 is 2 comma 2 times 1 plus 1 is 3. And then 0, 0 will go to 0 plus 3, 3. 2 times 0 plus 1, 1. 1 comma 1 will go to 1 plus 3 is 4. 2 times 1 plus 1 is 3. Lastly, 2 comma 4 will go to 2 plus 3 is 5, comma 4 times 2 plus 1 is 9. So now I have 1 comma 9, 2 comma 3, 3 comma 1, 4 comma 3, and 5 comma 9. And here is my g of x. Number 7, multiplying binomials and special products. So you have learned this from algebra class, and hopefully you guys do remember since you're going to use this extensively in calculus this semester. So when you multiply two binomial, you have to FOIL. You don't just multiply first and first and last. You gotta multiply first and first, and outer two, inner two, and last. Product of sum and differences. So when you multiply two binomials that are conjugate, and I do explain earlier what conjugates are. Conjugates are two binomials such that first term is exactly the same and last terms are the opposites. And when you FOIL them, outer two and inner two are the same but opposite signs. So they cancel out to be 0 and you end up only getting first and first, which is the a square, and last, which is minus b square. And therefore, when you factor the difference of squares, it becomes product of conjugate. So both directions we use intensively. So it will be really good to memorize that. Pascal's triangles are coefficients of expansion of binomials. So as you see, if you have any binomial to the zeroth power, since anything to the zeroth power is 1, you do get 1 here. And a plus b to the fourth power is a plus b, so their coefficient is 1 and 1. From there, the last ones are always 1. And then you could gain the middle by adding those two. So those two create this number. When you add these two, it creates this number. You add these two, it creates that number. When you add these two, it creates this number. You add these two, it creates that number. You add these two, it creates this number. So that's called a Pascal's triangle. So know that this is a plus b to the zeroth power. This is the coefficient of a plus b to the first power, so you get 1a plus 1b. When you multiply a plus b times a plus b, you get a squared plus 2ab plus b squared, so coefficient is 1, 2, 1. When you multiply a plus b times a plus b times a plus b 3 times, when you multiply out and clean it up, you do get a to the third power plus 3a squared b plus 3ab squared plus b to the third power. And this will be expansion coefficient of expansion of a plus b to the power 4. Perfect square trinomials. A squared plus 2ab plus b squared and a squared minus 2ab plus b squared are called perfect square trinomials, and they are then a plus b squared and a minus b squared. You also need to know or remember how to factor sum of cubes and differences of cubes. Now note that a squared plus b squared does not factor. It is always prime. However, a cubed plus b cubed does factor as a plus b times a squared minus ab plus b squared. A cubed minus b cubed factors as a minus b, and a squared plus ab plus b squared. Expand x minus 2 to the power 4. So let's say you didn't have anything here on the right hand side tables and you had to do this problem on your own. You can quickly draw the Pascal's triangle up to level 5 since it starts from 0's power. So here's the 1, 1, 1, and you get 1, 2, 1. And then the fourth one is 1, you add 3, add 3, last one's 1. You need one more. That will be 1, add 4, add 6, add 4, last one, 1. So this is the coefficient of your expansion for the a minus b to the power 4. So for this one, what you do is, first one's coefficient is going to be 1. So it's a 1 times, you're going to have all x to the power 4. And then next one's going to be coefficient 4. So you need to use that 4 for the coefficient for next term. And then you lose 1 power of that from here. So now you're only going to have x to the power 3. And your second term is negative 2. You're going to gain 1 of that. And the coefficient for the third term is 6. So you have a positive 6. And now again, you're going to lose 1 power of that. So you have only x squared. But now you're going to get second term, 2 of them. The coefficient of the fourth term is positive 4 again. And you're going to lose 1 power of that. And now you're going to gain 1 power of second term. So you get now third power. And the coefficient of last term is 1. But now you don't have any x. You're only going to have a negative 2 for all power of 4. And now you need to multiply that out and clean it up. So 1 times x to the 4th power is x to the 4th power. 4 times negative 2 is negative 8x to the 3rd power. Negative 2 squared is positive 4 times 6 is 24x squared. Negative 2 to the 3rd power is negative 8. Negative 8 times 4 is negative 32x. Negative 2 to the power 4 is actually positive 16. So here is your answer for this binomial expansion. Example. Factor 8x cubed minus 27. So you can see that this is 2x to the 3rd power minus 3 to the 3rd power. So you want to use this formula. So the first factor is going to be just without cube sign. So it will be 2x minus 3. And then open the parentheses. Now we're going to apply the second factor. And second factor can be made out of, second factor can be formed by multiplying your first term twice. So square the 2x, and you need to square 2 and the x, since ab squared is a squared b squared. You have a product. You need to square both. So you get 4x squared, and it is the plus sign for the middle term. So it's going to be plus. And what comes to the middle is multiplying the a and the b. So you get 2x times 3, which is 6x. And then last term, you just multiply second term twice. Since it's 3 squared, it is 9. So here is how 8x cubed minus 27 factors. So this is the answer. Make sure you know how to factor them. Number 8. Factoring with negative and fractional exponents. Example. Factor negative 3x squared plus 21x to the negative 5th. You are gonna see a lot of problems look like this semester. And even though you are good at factoring, sometimes with the negative exponent or fractional exponent, you get really confused. But it is really same strategy. When you factor, we take it out the lower power of the two common factors. So just remember to take it out the lowest power of all common factors. And that's what's gonna be common factor for all of it. So let's go ahead and do the problem. So let's just say I want to factor negative 3x squared plus 21x to the negative 5th. If your polynomial start by negative term, then you need to take it out the negative GCF. So negative 3 and 21, common factor is negative 3. And with x squared and x to the negative 5th power, which is the lower power of the two? Yes. It would be x to the negative 5th power. That is the lower power of the two. So that's what you need to factor out. Now, remember, when we multiply these two, I have to get the fourth term back. And with the power a to the mth power times a to the nth power, it is a to the m plus nth power. So negative 5 plus 7 gives you positive 2. And when you multiply now these two, you have to get the positive 21x to the negative 5th power. So it's gonna be negative there. And negative 3 times negative 7 is positive 21. X to the negative 5th is out. So now you've factored it. But because we do not leave negative exponent answer, you need to simplify this. And negative 3 is just a negative 3, so it stays there. But negative exponent needs to go to the denominator, and it turns it to a positive exponent. So the answer is negative 3 times quantity x to the 7th power minus 7 over x to the 5th power. Factor 9x to the 3rd power, quantity x minus 2 to the 5/2 power, minus 12x squared, quantity x minus 2 to the 3/2 power. So do one at a time. So 9 and 12, common factor is obviously 3. X to the 3rd power, x to the 2nd power, common factor is x squared. With x minus 2 to the 5/2, x minus 2 to the 3/2, lower power is 3/2. So you can take it out, x minus 2 to the 3/2 power, now open. So when I multiply these two, I have to get this fourth term back. So 3 times 3 gives you 9. X squared times x give you x to the 3rd power, and x minus 2 to the 3/2 power plus what power gives me 5 over 2 power? Well, 3 over 2 plus 2 over 2 gives me 5 over 2, and 2 over 2 is 1. So it is that what I have in there. Minus now, when I multiply these two, I have to get this back. So 3 times negative 4 is 12. X squared is out. X minus 2 to the 3/2 power is out. So that is it, right? However, you cannot leave your answer like that either, because this can be simplified. So the final answer will be then 3x squared, x minus 2 to the 3/2 power, 3x squared minus 6x minus 4. and that is your answer. Factor 7 over 2 x to the negative 2/3 power times x plus 1 square plus 3x to the negative 5/3 power times x plus 1 cube. So what do I do if I have a fraction? If there's a fraction number, it's just easier to make it a single fraction and just factor the numerator instead. So since this denominator is 2, make this guy 3 over 1, but times 2 by top and bottom so that it would have a common denominator, 2. So your numerator then is 7x to the negative 2/3 power x plus 1 square. And when you multiply 3 and 2, you get 6x to the negative 5 over 3 x plus 1 cube. Okay, now that will make it easier, right? 7 and 6 do not have any common factor. And between power negative 2/3 and negative 5/3, this is a negative number now, which is smaller. Yes, negative 5 over 3 is smaller. So that's what you need to take it out. Always take it out the lower power of the 2, whether it's a negative number or fraction. Doesn't matter. X plus 1 square, x plus 1 to the 3rd power, which is the lower power of the 2, x plus 1 square. So you're going to factor that out. So then what goes in there? Well, 7 was never factored out. So 7 needs to go there. And when I multiply these two, I have to get x to the negative 2/3 power. So negative 5/3 plus what number gives you negative 2/3? Then you need positive 3/3, right? And positive 3/3 is 1, so it will be just x to the power 1. Beautiful, right? And whole x plus 1 square is out, so it's gonna be plus now. 6 was never factored out. You took it out, x to the negative 5/3 power out, and x plus 1 square times what is x plus 1 to the 3rd power? That will be another x plus 1 that you need there. So now you clean up the bracket, and you also want to send this negative exponent to the denominator, since we don't want the negative exponent answer. So I have an x plus 1 square, and if I clean up the bracket, I get 7x plus 6x plus 6 over 2 times x to the negative 5/3 power comes down, it becomes positive 5/3 power. So my final answer is x plus 1 square, 13x plus 6 over 2x to the 5/3 power. Number 9. Inequalities on the number line involving absolute value. Example. Write each solution as a single inequality involving absolute value, which gives all the possible values for the variable. So the first graph, you would like to use variable t and write the absolute value expression that denotes for all t in the interval negative 2 to 8. So you can think of this as an absolute value function that is shifted 3 units to the right. And as you know, for x, or input, the shifting is opposite. Because it went to the right 3 units from 0 on a number line, you would like to actually use t minus 3. And because the distance from 3 to 8 or 3 to negative 2 is both 5 units, you can say that distance is less than 5 because these numbers are distance less than 5 from the center 3. So this would be single expression which gives all the possible values for the t. Next problem, they want you to use variable b. So from the number line, typically center is 0. Now it went to the left. Because it went to the left, you actually want to use the absolute value of b plus 2.6 because the center moved from 0 to negative 2.6. And you can calculate the distance from the center to the one of the endpoint by subtracting negative 2.6 from negative 2.2. Then that will be negative 2.2 plus 2.6, and it is absolute value of 0.4, which is 0.4. So distance from negative 2.6 to negative 2.2 is 0.4, and because it is a bracket, the endpoints are included, so therefore you will use less than or equal to. Now for the last one, they want you to use the variable y. This is not function y, it's just they're using input of absolute value function and they want you to use the input as a y instead of x. So it is the same concept. Since center is moved from 0 to 7, you will do actually absolute value of y minus 7, and the distance from 7 to 10 or 7 to 4 is 3. And since endpoint is included, you want that to be less than or equal to positive 3. So here is the answer. Number 10, factoring with absolute values. As you know, absolute value of negative 3 or absolute value of positive 3 are equal. So when you just have an absolute value of negative a as a single factor, you can actually call that an absolute value of a. And absolute value of a minus b is equal to absolute value of b minus a. In general, a minus b is not equal to b minus a because the subtraction is not commutative. However, if you put an absolute value over them, they are equal. Example, factor absolute value of negative 8 plus 12x. So this is equal to absolute value of, what is the common factor of negative 8 and positive 12x? I told you if your fourth term starts with a negative, factor out the negative GCF. So that will be negative 4 times positive 2 minus 3x. However, note that this is equal to absolute value of negative 4 times absolute value of 2 minus 3x. It doesn't have that in the box, but you can add one more. So absolute value of a times b is equal to absolute value of a times absolute value of b. You can do that with a product or quotient. So this is equal to 4 times the absolute value of 2 minus 3x. And this is as far as you can get because we don't know whether 2 minus 3x is a positive or negative, so you cannot get rid of absolute value. But absolute value of negative 4 is 4, so you could get rid of that absolute value for the negative 4. Factor absolute value of 12x squared minus 20x plus 3. So again, you could factor this. Since it's a trinomial of a leading coefficient, not 1, I'm gonna break 12x squared as 6x times 2x. And to come up with a negative 20x, when I combine inner 2 and outer 2, I can see that I need a negative 3 here, and I need negative 1 there. So that when I multiply negative 1 times negative 3, I get positive 3. Outer 2 is negative 18x. Inner 2 is negative 2x, which combines to negative 20x in the middle. So this is the right factoring, and factor is 6x minus 1 times 2x minus 3. And because absolute value of AB is absolute value of A times absolute value of B, you could rewrite this as absolute value of 6x minus 1 times absolute value of 2x minus 3. And that's as far as you can get. Composite functions. Example, evaluate and simplify each, given that g of x equal 1 minus x squared. So g of x is 1 minus whatever the input is, you need to score the input. So g of x minus 5 will be 1 minus input square. And when you clean that up, 1 minus, this will be perfect square trinomial when you multiply out. So it is a squared minus 2ab plus b squared. So when I distribute the negative now, I get 1 minus x squared plus 10x minus 25. So my final answer becomes negative x squared plus 10x minus 24. Can you also do g of quantity x plus h minus g of x over h? This is called the difference quotient. I think you also saw this in algebra, but this involves definition of derivatives, so you're going to use it a lot in calculus. So let's go ahead and do this. So this is equal to g of x plus h is, remember your g function says whatever your input is, do 1 minus input square. So g of x plus h is 1 minus input square minus g of x, and g of x, you can just plug g of x there, which is 1 minus x squared, over h is not applied to g, it's just h, so you just copy h, which is equal to, by order of operation, you gotta do exponent first, so you're gonna multiply that out. It's gonna become perfect square trinomial. It's a x squared plus 2hx plus h squared. You can distribute the negative for this guy, and I will get negative 1 plus x squared over h. One more time, I'm going to distribute this negative. For all three terms inside of a parenthesis, I get 1 minus x squared minus 2hx minus h squared minus 1 plus x squared over h equal to negative x squared plus x squared cancels out, positive 1, negative 1 cancels out. So all I have is negative 2hx minus h squared over h, but I can see everybody have a h. So you can factor out the h from the top. You get negative 2x minus h over h. So now that you have a product over product, you can cancel h them. So your final answer will be negative 2x minus h.